In a previous video we invoiced the hopper popper and measured how high it would go at 7.4 grams. This ball is
13.4.
13.4 grams. And Zyto starts to go higher.
Right.
We're going to measure, we're going to invoice it, put the ball in it because it's invoiced, and then pop it. Except if we did it like that, it would hit the ceiling.
Okay, so as my grandson said, we're going to invert the hopper popper, put the ball in there, let it go, and see how high it goes. So in the next portion, you'll see.
The next question, I'm ready.
Okay, so I'm inverting the hopper popper. I'm going to put the ball in it, and I'm going to put it on the floor, and then I'm going to go up the ladder real quick and measure how high it goes. We're going to do 8 trials. We're not going to video all 8 trials. We'll just do them ourselves. It takes a little while to get started, so be patient. Okay, hurry up, ball. It usually goes by itself.
That's it.
Okay, it was right about here. That's the first one. All right.
Now I'm going to get the ball.
Okay, I think what we'll do it one more time on the video, and then after that we'll just mark it, and then we'll put it on a spreadsheet and tally up the results. Okay, so that's trial number 1.
This will be trial number 2. Okay.
Okay, it looks like a little higher. Okay, so why don't we stop the video now? Stop the video now. Okay, during this part of the video, we measured the height that the ball went up when the hopper popper got inverted and popped. And we measured 9 trials. We speeded up the video, so we did a total of 9 trials. So you can take a look at the data after we finish this part of the video. Okay, we're going to now analyze the data for the measurement of the energy given off by the hopper popper to the ball. We measured the height. We did 9 trials that the blue ball went up. This number here, 98.25, is the distance to the bottom of the paper that I placed on the wall, and it's in inches. And then I took that paper, after we did the 9 trials, I took that paper off and measured the distance from the bottom of the paper and to the mark. And then I added the distance from the floor to the bottom of the paper to get the total distance. I changed that from inches to centimeters. So these are the 9 distances in centimeters, and this is the average. The potential energy is equal to the mass, m, times acceleration due to gravity, g, times h. Now g is 9.807 meters per second squared. So every second the velocity changes by 9.807 meters per second. The mass of the ball was 13.2 grams, which is 0.0132. This should be kilograms here. The height, I changed it from centimeters to meters. So the height was 2.780 meters. If I multiply m times g times h, I get the potential energy in joules, and it's 0.360 joules. Now the hopper popper in the previous video, as you'll recall, we measured the energy that the hopper popper gives itself when it flips over. And that was 0.398 joules, a little bit more than this. So not all of the energy that is given to the hopper popper when you invert it is transferred to the energy of the ball. And so if we take the energy of the ball over the energy of the hopper popper times 100, we'll get the percent. And that turns out to be 90.4%. So it gives most of its energy to the ball, but some of the energy is lost. It probably stays with the hopper popper. Hopper popper jumps a little bit even when it has the ball in it. Okay, so we've determined that the hopper popper gives off a large portion of its energy to a ball, shoots it up into the air, and the kinetic energy it gives the ball is converted to potential energy as it rises, and then it stops rising and it has no kinetic energy and all potential energy. Okay, thank you for your attention, and we'll see you next time.